Welcome to another Mathnificent conversation. Today features simplifying radical expressions. It's your nerdy bestie Lex. Grab your pencils and let's go. The steps for simplifying a cube root are very similar to a square root. We're still going to write the prime factorization of the number, but instead of circling twins, we're going to circle triplets. So if you have three of a kind, you can circle and that triplet will come out of the radical as a single number. So let's get started. Okay, we want to simplify the cube root of 32. We know it's a cube root because we have a 3 inside the root. So step one, we're going to take 32 and write the prime factorization. 32, we can start with 2 times 16. 2 is prime, so that branch is done. 16 is 2 times 8. 2 is prime, so that branch is done. 8 is 2 times 4, and 4 is 2 times 2. So we can rewrite the cube root of 32 as 2 times 2 times 2 times 2 times 2. I have a set of triplet 2s, but I don't have enough 2s to make another set. So that set of triplet 2s will come out as a single 2. And I'm left with the cube root of 2 times 2. So my final answer is 2 cube root of 4. Next, we want to simplify the cube root of 135. Take 135 to the side. 135 ends in 5, so I know it's divisible by 5. And it's 5 times 27. 5 is prime. That branch is done. 27 is 3 times 9. And 9 is 3 times 3. So 135 can be rewritten as 3 times 3 times 3 times 5. I have a set of triplet 3s that will come out as a single 3. And I'm left with the cube root of 5. And now we want to simplify the cube root of 192. We'll start with 192. 192 is even, so I know it's divisible by 2. That's 2 times 96. 96 is also even, divisible by 2. 2 times 48. 48 is 6 times 8. 6 breaks into 2 times 3. And 8 is 2 times 4. And then 4 is 2 times 2. So 192 can be rewritten as I have 1, 2, 3, 4, 5, 6 2s. 1, 2, 3, 4, 5, 6. And 1, 3. So in this case, I have 2 sets of triplet 2s. Each will come out as a single 2. So 2 times 2 on the outside. And I'm left with the cube root of 3. So my final answer is 4 times the cube root of 3. Now I want to simplify the cube root of 375. I'm going to take 375 off to the side. 375 ends in 5, so I know it's divisible by 5. It's 5 times 75. 75 is 3/4, so 3 times 25. And then 25 is 5 times 5. So 375 can be rewritten as 5 times 5 times 5. n times 3. I have a group of triplet 5s that will come out as a single 5. And I'm left with the cube root of 3. This same prime factorization method works for any root. So I'm going to denote the root as an n just to say it could be any number. That's an integer. So now after our prime factorization, we're going to circle groups of n. So for example, if I want to simplify the fifth root of 96, I need 5 of some prime number in order to bring it out of the radical as a single number. So let's take a look. 96 is divisible by 3. 9 plus 6 is 15. 15 is divisible by 3. So 96 is divisible by 3, and it's 3 times 32. 32 is even, so it's divisible by 2. 2 times 16. 16 is 4 times 4, and each 4 breaks into 2 times 2. So the fifth root of 96 can be rewritten as 2 times 2 times 2 times 2 times 2 times 3. And you'll notice I have a set of 5 2's that will come out as a single 2. And we're left with the fifth root of 3. So 2 times the fifth root of 3 is our final answer. And let me add in that this n should be a positive integer greater than 2, greater than or equal to 2. For our last example, let's simplify the fourth root of 405. We'll take 405 to the side. 405 ends in a 5, so we know it's divisible by 5, and it's 5 times 81. 81 is 9 times 9, and each 9 breaks into 3 times 3. So 405 can be rewritten as 3 times 3 times 3 times 3 times 5. I have a group of 4 3's that will come out of the radical as a single 3, and I'm left with the fourth root of 5. So again, the prime factorization method works as long as n is a positive integer and it's bigger than or equal to 2. You can do this same method. Just remember you're looking for groups of whatever that root is. I hope this video was helpful. Remember, you're magnificent and you're brilliant, and I hope to see you in the next video.